Now, in this example, things get just a little bit more complicated because this time you can see in these pictures of shorthorn cattle that there's not just two phenotypes, but there are three. There are these ones that we call red, there are these ones that we call white, and these ones we refer to as roan, which is sort of they're red and white. But interestingly, there are not three different alleles at the gene locus controlling cattle colour. There are only two different alleles at that gene locus. So how does this work out? Well, it turns out that the allele for red colour is not dominant to the allele for white colour, and neither is the allele for white colour dominant to the allele for red colour. They're both equally dominant. They're both equally likely to be expressed in the phenotype of a heterozygote. So what sort of allele symbols would we give? We're not going to give a capital letter for the red one and a lowercase letter for the white one. That would be misleading because it would suggest that red was dominant to white. And we're not going to give a capital letter to the white one and a lowercase letter to the red one because, again, that would suggest that white was dominant to red. So what we really need to do is we need to give them both a capital letter because they're both dominant. But obviously that's a bit confusing because we won't know which C is which. So what we have to do is we have to have some sort of way of differentiating them. Some people like to call them C1 and C2, and that works, that separates them. But what I like to do, and I think what is probably normal to do, is to use some sort of a superscript letter. So we might put an R on this one to tell us that that's the allele for red coat colour, and a W on this one to tell us that that's the coat colour for the allele rather for white coat colour. You might ask at this point, why don't we just call this one big R and this one big W? I bet you thought that, didn't you? Well, the reason is because it's just a convention. It's sort of a notation convention that we always use a capital letter for the allele for the dominant trait and a lowercase letter of the same letter for the allele for the recessive trait. It makes it less confusing when we start looking at several genes at once, because if we had R and W and then there was another gene involved as well, and it might be a P and a Q, it just starts getting confusing. This way we know that these two are both different alleles of the same gene that we're calling C, or we're referring to as C. So we want to keep that letter the same, but we obviously need a superscript to differentiate between them. So the genotype of a red cow then would be big C R, big C R. The genotype of a white cow would be big C W, big C W, but a heterozygote, one of these roan cows here, will have the genotype big C R, big C W. Apart from that, if you understand that, and we call this codominance, by the way, because both the red and the white are dominant. And there's something very similar to codominance that sometimes you'll hear people talking about is incomplete dominance. We would call it incomplete dominance if this cow, instead of being red and white, if its hairs were pink. So they were neither red nor white, we'd call it incomplete dominance. They're not completely red, they're not completely white. But in this case, it has red hairs and it has white hairs. They're completely red, completely white hairs side by side. We call it codominance. In reality, though, there's no real difference between codominance and incomplete dominance, because even if its hair was pink, if you were to look at those hairs at a molecular level, there would be red proteins and white proteins, red pigments and white pigments side by side. There would be no pink pigments. So, it's really the term incomplete dominance is really an old-fashioned term before people understood what was really going on. Anyway, if we were crossing, say, let's say we cross two roan cows, so we're going to cross this cow with another roan cow, we would do the same as what we've done in the past. Nothing different here. We're just going to draw ourselves a Punnett square. We're going to say, well, what kinds of gametes, what kinds of sperm and eggs can this, I suppose I shouldn't refer to them both as cows, should we? What sperm can this bull produce? Half of its sperm will have a big R, and half of them will have a big C with a superscript R, half will have a big C with a superscript W. Same with this cow, half of her eggs will have a big C with a superscript R, half will have a big C with a superscript W. Remember, it's the C, this is important, it's the C that's the allele, not the R. The R is just a superscript to tell this C apart from that C. And you might think, what's the difference? But again, thinking about it the right way makes all the difference when things get a little bit more complicated. So if this egg is fertilized by that sperm, we're going to end up with a zygote that's homozygous for red. This will be a red cattle. If this sperm fertilizes this egg, we're going to get a heterozygous offspring, and it will be roan in colour. If this sperm fertilizes this egg, we're going to again get a roan-coloured offspring. And if this sperm fertilizes this egg, then we would have, I hope you can see, a white offspring. So in terms of the outcome here, we would have 1/4 of the offspring. 1/4 of the offspring would be red to 1/2 roan to 1/4 white. Or we could say there's a 1 to 2 to 1 ratio. And that's actually quite a useful ratio to remember, a 1 to 2 to 1 ratio, if you're crossing two heterozygotes for a gene which is codominant.